Hi, everybody. My name is Ian Cookson. Yeah, I'm a product manager here at Oracle. Joining me in and answering most of the Q&A questions will be Gerald Venzl, yet another product manager from Oracle. Gerald's the product manager for application development. Okay. While I'm the product manager for application continuity and Oracle clusterware. I get the bottom and the top of the Oracle stack to represent. And today we're going to be talking about the application continuity part, and specifically more about how to build or what to do about your applications, how to build and deploy them for zero downtime, particularly to avoid the impacts of planned maintenance events, patching. Okay. So here we'll get started. As a reminder for everybody, I'm presuming people know what application continuity is. That's why you're here, or maybe you're just curious. Well, application continuity is a feature of the RAC database itself. It's built into the code. It's there for everyone to use. And it's meant to augment the base functionality that we've had there for decades now, since 10.2 of the release of the database. But application continuity actually replays interrupted database requests. And we'll talk about what that really means in a moment. But the replay is the important part. It replays when a database request or a submission from a session that you're running is interrupted. And you don't see the results otherwise. So interruptions, we cover basically any unplanned events, obviously. If things crash, we replay the event, the session or database request and return the results to you automatically. You don't do anything, you just sit there and lap up the results. You probably wouldn't even notice it. We have a lot of customers doing this right now, mission critical applications primarily, because this is just another level of high availability. Okay. We're building on top of that concept of the maximum availability architecture that RAC databases, data guard, and so forth espouse and promote. But more commonly, we've got interruptions due to planned maintenance, patching primarily, that everyone is facing these days. And really, that's what customers want. When people come to me and say, I need application continuity. Well, really, they need a solution for planned maintenance to prevent the impact of any patching processing so that their users are never interrupted. Their user workload processing and so forth is not interrupted as they do a rolling patching process on a RAC database or anything along those lines. And it doesn't really matter whether they're in the Oracle Cloud, of whatever flavor that might be, or they're doing it purely on premise. Basically, the impacts are always going to be the similar way, and we provide a solution that works across the board. Works exactly the same way in the cloud or on premises. So let's try not to differentiate too much there. There are some slight differences for timeouts and manageability and operations, but essentially, as far as configuring or developing your application, there's no difference. Okay. So but again, we're enhancing the base capabilities of the RAC database. Very profound ones that people just don't normally take advantage of. And we'll talk a bit more as we go through about that. And once we've got application continuity configured for that level of interruption, well, the same applies for unplanned. So throughout this presentation, I'll be talking about how do we manage planned maintenance without impacting users. Zero downtime, zero impact, and so on and so forth. And most of those rules or changes or configuration changes that I'm recommending will also apply for unplanned. So let's just assume that, keep it in mind that we're actually going to solve all these problems all with one fell swoop. Okay. So first of all, I talked about a database request, and we better understand what that really is first. It's kind of fundamental. This is something that was introduced with the Java standard JDK 9 some years ago, and first introduced to the Oracle database world with 12c. Okay, and we incorporated the functionality into the Oracle pool, connection pools at that point, whether it's the Universal Connection Pool, which is UCP, the OCI session pool for Oracle call interface applications and clients, ODP.NET, and also for WebLogic using the Active Grid Link connector. Okay. So that's when we introduced it, and it's as part of the Java standard. It's been slow to be adopted, but it's gradually getting there. In fact, the most recent adoption has been Red Hat's JBoss application. Incorporates explicit boundaries into their pooling mechanisms. Okay. But we want you to be able to use it no matter what, and so we've incorporated into the UCP or Universal Connection Pool and so on and so forth that you can configure for other applications, your applications you already have in place. Now, the way this all works is request boundaries are meant to delineate the unit of work. Everyone talks about what the unit of work is for various things. And in this case, it's the unit of work for your particular session. And your session may have lots of these requests, but typically it sends one off, it connects to the database, gets a connection from the connection pool. Okay, that begins the request. That request boundary is injected by the connection pool. Okay, the application doesn't have to do this. It submits a number of statements, SQL statements, PL SQL, whatever it might be. It may commit once only, but it may not. It may just be queries. So it doesn't matter. When it returns the connection to the pool, that tells the connection pool to inject an end request marker. So now we've got the unit of work defined by this begin request marker and this end request marker. Explicitly defined. It's very clear. And the logic, it depends obviously, completely on the logic of your application, which means it's correct, right? Because your application must be correct. And we use those connections, that explicit boundaries throughout processing as we go further through this. Now, what we did in later releases of the database, primarily, actually in 19C, was introduce a new way of looking at this as well. For those applications that do not use Oracle connection pools, we have to be able, and there are lots of those, okay? We have a few ourselves. We have to be able to manage the same delineation of the unit of work, but more implicitly. We have, without a connection pool, there's no way of injecting begin and request boundaries unless you actually code it into your application. So what we introduced was the transparent application continuity configuration, whereby the database looked at the state of the session, your session, and if they saw session state changes of any significance, it would assume that the request is you're going to be beginning a request or ending a request. Now, beginning a request, obviously, if you open a cursor, it kind of suggests, yeah, you're going to do some work. Okay, so let's begin that request. We'll put the marker, lay the marker down here. And if you commit or close cursors, then that kind of suggests that you're ending your request. So again, we inject the boundary accordingly. So either we get the explicit boundaries from the connection pool, or we get the implicit ones from the database itself as it looks at the session. And we work on that basis. We have one or the other. Obviously, prior to 19C, you had to use an Oracle connection pool. Now you have the option of using a Oracle connection pool or no connection pool. Okay. We still think explicit boundaries are the best because it depends on your logic, the logic of your application to derive what those request boundaries should be. Okay. And we use them throughout, as I mentioned, whether it's for draining, for planned maintenance. Load balancing across the cluster. We load balance on the request boundaries. Okay. Obviously, we don't shift between halfway through the request. Recovery and replay and so forth. It's all managed through the request boundaries or at the request boundary layers. Okay. In performance metrics as well. Okay. So configuration options. If you're going to be using explicit boundaries and so forth. From Oracle, I've mentioned you've got the UCP, which is the Universal Connection Pool, WebLogic Active Grid Link, okay, ODP.NET unmanaged, and the OCI session pool. These are all Oracle supplied connection pool mechanisms. Okay. If you're doing so, if you're not using any of those explicitly, but you want to use an application server of some sort, it uses typically Java, then you probably want to use UCP, because UCP can be configured to work with any of these other Java application servers. Put the star beside the Red Hat JBoss because now they don't need UCP. In fact, we recommend just using their default pool because it supports explicit boundaries very well in the latest release of the JBoss. Okay. Then, of course, if you want to code it actually yourself in your application, then you can implicitly begin request and end request, obviously without pools. Okay. But this stuff off to the left is probably the best start for you. Okay. The Oracle solution. So what are we talking about here? We're talking about planned maintenance and the different component steps to it. And I mentioned earlier that effectively the database does it all for you, but we enhance it with application continuity. And then once we get sorted this out, we're going to talk a bit more about how you make this all work. Okay. So let's assume we have a 2-node cluster. Okay. High availability is important here. So we're talking about a clustered solution on rack. At some point, we initiate the drain. In other words, we want to start planned maintenance of some sort on node 1. We want to do some patching. And prior to that, beginning of that, we want to make sure all the work that's actually submitted to node 1 completes, gets processed. But at the same time, we don't want to just turn away any new work coming. So what we do is we relocate the service to which we're actually connecting. We have to use a database service from node 1 to node 2. From node 2 now, all the new connections are going there, wherever that service is running, in other words. Okay. At the same time, of course, well, we've stopped any new work coming to node 1, but we want to finish the processing there, and we effectively drain it, as we call it. The term is workload draining. And we're actually processing the in-flight database requests and sessions, and to their conclusion over a particular time, the drain timeout, as we call it. After the drain timeout, of course, expires, there may still be something outstanding. We haven't finished everything. Okay, ideally, we make this drain timeout long enough to capture, or in other words, drain everything. And that's really what you should be aiming at. And this is what's been available to you since 10.2. Okay, you just drained as long as necessary, and you finished processing everything. Remember, all the time here, we're draining in node 1, but all the new connections are being processed anyway on node 2. So there's never a point in time when users cannot connect to the database and have their workload processed. This is really important. So before we actually start draining on node 1 and refusing any new connections there, new connections are actually being made on node 2. And you can see the workload picks up there and so forth. So at the end of the drain timeout, if we specified it a bit shorter than some of the database requests require, then we're going to basically terminate the database instance at that point, and resulting in errors or exceptions being returned to the users. Maybe that's not what you want, right? So that's where application continuity comes in. And, Number 4 is that, in fact, that application continuity. So instead of, we actually do terminate the in-flight requests, but in fact, we then reconnect on node 2, because that's where the service is running, and replay them from start to finish, the entire request. So that begin request marker all the way through to the end request marker is replayed completely on node 2, and the results return to the users. And you think, well, that's great, but what if my request is really long? It's not going to work very well for me, because I'll have to process it twice, in effect. And yes, that's true. This is really designed for OLTP and maybe short-term batch. And in OLTP, the transactions or database requests are really short. So what we found is if within this rack environment, this type of failover scenario, users don't even notice it. It's so fast. Okay, and we've got a lot of experience now with high demand customers and low ones too on processing, and we challenge any of them to tell us if they can notice it, and we haven't heard of anybody, saying yes, we can see it. No, it's so fast, you're not going to notice the difference. The key here is we replay the transactions or database requests automatically at the end of the drain timeout. We play them back in their entirety and guarantee the results exactly as they had once been submitted. This is extremely important for us. The integrity of the transaction or database request is really critical. So we want the results to be exactly the same as they should have been processed originally, including mutables, which are like function calls and so forth that we typically should return different values. This includes sysdate, systime, next val on your sequences. They should all return exactly the same values as when they were first submitted. So users will never see the difference. All automatic for them. Okay. And eventually we get to a steady state on node 2. And during that period of time, after the drain timeout, well, your patching is taking place. And if we extended that timeline further, we'd bring node 1 back into the mix, and load balance would occur, and we get work on node 1 and node 2 at the same time, and so forth. And then we could shut down node 2 and repeat the patching process there, all without noticeably impacting the users. Users won't notice it. Pretty kind of belabored that point, but that's what the whole point of this presentation is. Okay. Now, because we're talking, I'm assuming most of you out there are application people or application developers or owners who are deploying these applications. We're not going to dwell too much on the DBA tasks. Just say that they have to get done first, and you probably want to do them in conjunction, in consultation with you. Okay, have them due to your specifications. The DBA itself or themselves must add the database services or enable the database services specifically for you based on your workload. And there are 2 configurations, as I mentioned earlier, one for application continuity, the original as a 12C, and that require the use of Oracle's connection pool, or the TAC one, the transparent application continuity configuration that could work with explicit boundaries. In other words, with an Oracle connection pool or not. Okay. And the or not is really attractive to those who don't want to have to be changing their configuration or their application and so forth to comply with the requirements for the original configuration. Funnily enough, also, you need to open port 6200 on the database server nodes. Each node has to be open. Now, default is 6200 for the Oracle notification service. We use this to send out notifications to the end user applications that there are state changes on the database services to which they're connected. More on this in a minute, but basically it is, just sending out a message saying, you're going to get interrupted if you don't do something. Okay. And then we'll talk about how they do about it. And I mentioned mutables and so forth. The mutables in your database that you will be accessing, the DBA must grant keep on them. In other words, keep the values as constants, specific for application continuity usage. Okay. Next val on a sequence, sysdate, systime, and so forth. We're gradually adding more of these function calls to the list of mutables we support, but you do it once, you don't do it again. And it's almost like it should be a routine. If you're deploying using application continuity, just grant keep on them. Have it done with. Okay. So let's assume it's done. This is the DBA's job. You don't have to worry about it. Just make sure you get it done and done right. You can evaluate whether you're receiving the fan events and so forth. There is a utility available for that. But in reality, it's pretty straightforward. And we'll show you how to take advantage of that and receive those ONS broadcasts in a moment here. Yeah, we'll just skip that one. Okay, planned maintenance, processing steps. Okay, so I said we're going to talk about planned maintenance, and we have so far, and I want to just talk about them in a bit more prosaic way. We've got 4 steps really in processing the planned maintenance as far as the application is concerned. The initiation of it, in other words, how we get it started. Notification, how we send notification and receive notifications to the applications, to or from, and so forth. And the reaction of the application itself, what it has to do in response to that. And then what's happening lower down the processing stack, in other words, what's happening at the database level. And we'll talk about each of these as we go through. On the initiation, basically it is a matter of a DBA and or utility script, whatever, issuing a SRV CTL command, which is a server control command to relocate or stop the database service to which you're connected. Okay, you don't need to know this much because, in fact, that's what the DBA does for you. Well, at the time of when planned maintenance is expected to start, and he'll do that, and you can actually specify a drain timeout then, or rely on the one defined for the particular service. Essentially, what happens there is we start draining, and we saw it in the graph I showed earlier. When that is initiated, the service is relocated or stopped locally, but is ensure that if it's a relocate, it's started elsewhere. Okay, so at no point in time again does the user not able to connect. This is one of those fan notification situations because there's a state change on the database service. Okay, and the fan notification is broadcast via ONS. Okay, so that's that part. Then we have a notification. In other words, the application receives the planned down event via ONS. It's planned down. This is because we've initiated it as opposed to hard down, which is like a crash. Now, there's 2 options here. If you're using a connection pool, then or you coded to handle the ONS notifications, then that's fine because your application will have the libraries under which the ons.jars or whatever it might be to receive the ONS notification and then follow on reaction. If you haven't done that, that's fine too, because what we'll end up doing is routinely configure your application to send a connection request every time it wants to do some work. And when it sends the connection request, the database will say, go elsewhere. In other words, go to wherever the service is running somewhere else on my database, on the cluster, I should say, and we'll be good. We'll talk a bit more about that and how to configure that. Then in reaction to all this, of course, the service is running somewhere in the cluster. And so the application must be configured to automatically reconnect to wherever that service is running, regardless of how it's received notification that it's not running where it thought it was. Okay, so no matter how it's received notifications, the reaction is simple. It automatically reconnects where the service is. And once that is happening, then we know what the database will drain the in-flight work and send completion response to the application, or replay the request on an instance wherever we can reconnect the application. So pretty straightforward, much the same as what I've talked about, is just a bit more step-by-step detail. So how are we going to make these happen? Essentially, DBA does the first part. Okay, initiation is all up to the DBA. You don't worry about that. Okay. We do the second bit. We're going to talk a bit more about that in detail. And then the third is pretty straightforward. Again, we'll talk about that. And the database actually does all the rest of the work. So do you need to do much of it? Only the middle two pieces. Pretty straightforward. Okay. So notification. Talked about this one already. But anyway, we've initiated the drain. So now your application has received the planned down event. Okay. To do so, we have to make sure we use the right connection string. Okay. But we also make sure, if we're using JDBC, we have to configure the ons.jar. This is the jar or library that contains all the code to handle ONS notifications. Okay, so your connection pool or app server will be able to understand this, use it accordingly, and so forth. Okay. It does not mean you change the code in your application. You just change the configuration of your app server or connection pool to include ons.jar. If it's an OCI or ODP.NET application, this is much simpler, in fact. You basically have to set the AQ HA notifications on the database server. This is primarily to receive the FAN events. And in addition, if in ODP.NET, you probably have to change the HA events to true. Okay. So this is part of your connect string. Now that correct connection string, as I mentioned here, I'll show you in the next slide. But it is, if you use that connection string, it will automatically register your application to receive ONS notifications. So again, how do I make FAN work? You use the right connection string and you configure ons.jar or whatever, and you're done. It's that simple. It's no longer complicated. Once was, I understand that, but it isn't anymore. And this connection string is the same we use throughout our cloud deployments and recommends heavily for everyone in the requiring HA connectivity. If we're not using a connection pool, then we need or have not been able to configure ons.jar, ONS sections responses. Then we need to rely on connection requests. And connection request is basically a call from your application or application server pool, whatever it might be, to the database to check whether the connection is valid or not. Can I make a connection here or not? Because your application is used to making the connection on node 1. Now, and you'll keep doing that. And every time you send that request in, you get a response, that connection request connection test to the database. The database will respond accordingly. Now, in most cases, because the instance is working fine, it'll say, yes, send me whatever you like. You can make a connection and continue work here. But if the database itself, the database instance is being set to drain on that particular service, then the database will actually kind of like say, no, we're not going to allow you to connect here, go somewhere else, because we know the service is running elsewhere. Okay. So even though if you're not receiving ONS notifications, you can still test whether the database instance is draining or not. Now, your application or application server may have will likely have this capability built into it. Very rarely do we ever hear of that not being the case. But the connection tests are slightly different from one application to another. And yeah, there's pretty much a common set that people recognize. But if you get a specially different one, the DBA may need to add it to the database, and that's quite all right. You make custom ones if you wish. Okay. So first of all, connection strength. This is well documented in some of the links I'm going to show you later at the end of the presentation, but this is the format you should be using. I'm not going to go into great detail because it's explained in those documentation for us. Key points here, though, I want to make it 2 key points. The address list, we have 2 within the same description. And the first one's the primary, in other words, where you're running locally. And the second address would be the secondary site, okay, if you're using Active Data Guard. If you're not using Active Data Guard, you don't need a second address. Just use the first one, and it's just for your rack. And you use the scan VIPs, okay, or the host. You're connecting by the scan VIPs, okay. And notice the service name here. Well, we call it Gold Cloud, obviously, but you can call it whatever you like, okay. That's your connect string, okay. Very simple, okay, but best performing and simplest. Make sure it's stored in a central reusable location. Don't code it directly into each of your applications. That's kind of a poor approach to it. tnsnames.org or an LDAP server, the right place to put it. Now, connection tests, kind of dwell on this a little bit, but it's pretty straightforward. On the database, you can go, the DBA can go and query which ones are actually enabled. DBA connection tests, right? Okay, so it's pretty straightforward. In 19C RU10, in other words, 1910, we added the ability to query the user env variable drain status. And you can check to see whether you can drain or not, or is draining or not, okay, particular for that session. So examples are what connection tests are configured or configurable. WebLogic, they're enabled by default, by the way. Is usable as cheap, is virtually the same as invalid. Basically, it's a ping test or a test on a socket by default, and you can increase the level of that, the cost of it, if you like, to be a full round trip, but typically most people use is valid at the base level. WebSphere, JBoss, Apache, and so forth. They nearly always use a lot of select ones from Dual. You'll notice that. You'll see, and if DBAs will recognize that, they see it a lot. These are just the way they are. It's not that you have to configure. You can add different ones if you wish. Okay. Pretty straightforward. Now, for various packaged applications, as I mentioned, they nearly always have this configurable. Okay. And these are the ones that are there for PeopleSoft, Siebel, and so forth. You can also create your own, such as the example we have down here. You can check the status every 60 seconds or whatever it might be, and you check the OCI attribute server status. Okay, it's for an OCI application. So we've covered off initiation, which is the DBA did. Get the ball rolling. We've talked about notification. In other words, how does your application know things are draining, and what does? And now we're talking about what does it do in response to that? What's the reaction? How do we make this smooth transition to reconnect elsewhere, wherever the service is running, without the application or user being aware? And yeah, because the application can be configured to automatically reconnect to wherever the service is running. It's it's dead easy. If you're an OCI or ODP.net, you don't do anything. I can do that. If you're using JDBC clients, which it seems the most common these days, set the pool or driver property to fast connection failover enabled equals to true. And this is usually referred to as FCF, or fast connection failover. Okay, so what happens there is your application, whatever it is, has submitted a call to the database as part of its database request and is waiting for a response. And it waits, and it waits. If something's happened to that instance, or the service, or whatever, you could be waiting for the amount of time for the TCP IP timeout, which could be anywhere from 10 seconds to how many minutes? I don't know. Okay, you don't want to be doing that. You want to get interrupted. In other words, you want a fan event to tell you that something's gone wrong and you need to do something about that. You need to react. In which case, fast connection failover is there's a response to that. We automatically interrupt the wait state of the client, and it automatically is the first piece. That's the ONS part, or fan, and then it reconnects automatically to wherever the service is running. Okay, so that's the key piece here. If you don't do this, you just wait. Everything works fine, but you're waiting a long time potentially, and no one really wants that. Very little to actually be done about this. Obviously, pool a driver property for the JDBC clients. That's about it. Okay. And that's about it. Now, so basically, if we look back here, I should just reiterate where we were with this. Sorry, I should have included this earlier. We had this position. We did the initiation, the DBAs did the work. Okay, we've got the service created, of course. We relocate the service and so forth, or stop it. Fan notifications are broadcast by ONS. Notifications are received and drive out the reconnection through FCF in the reaction. The response is that the database itself will drain the work from in-flight sessions and send the results back to you automatically. Or if they do not drain completely during the drain period or the drain timeout, then they will be automatically replayed. Okay. Pretty straightforward. I don't think there's anything. You just have to adopt some of these things, these pieces, and recognize when they are required. Now, on top of that, there's some basic recommendations we have to make this all work. Okay. As opposed to just saying, don't do this, I'm going to put it in a more positive light and say, do these things. And it's a pretty short list. I could talk for hours on each of these, but we won't. The first one's pretty straightforward. It's obvious. Always use the latest available client drivers or libraries. Can't say that how stress this strongly enough. They're always backwards compatible. Yeah, forwards compatible too. But the idea is you get the most recent versions to get the functionality for them, get all the most recent bug fixes, obviously, but also you get performance enhancements, one of the latest ones and so forth. So always go with the latest. And it's a fairly simple swap out, you might say, as well. The upgrade path is much simpler than it might be for a database per se. Okay, so now the connection, those drivers and so forth are always available for you for download. They're also distributed as part of the database distribution. Okay. So if you're looking for the jar sets, the ons.jar, ucp.jar, and so forth, you can get those from the database home, or you can get them from Maven and so forth. Along those lines, use an Oracle connection pool. I've kind of made this point already, because you want to insert explicit request boundaries whenever possible. Note that you can use the Red Hat JBoss functionality itself if that's what you want to do instead of using UCP under it. That's fine. It works really well. Okay. Otherwise, for your web JDBC or Java web servers or application servers such as WebSphere and so forth, configure them with UCP. It works for Spring. It works for WebSphere. In fact, IBM publishes a lot of papers of how to do it for WebSphere. They would prefer you to use UCP than their own pooling mechanisms. Okay. Specifically for application continuity and training on Oracle databases. So do that. That means you need to use the UCP jar in the Java JDBC configuration. Okay. A lot of JDBC stuff here because that seems to be the flavor of the month. Lots of people are using it. Driver statement cache in place. So yeah, for JDBC, always use the driver statement cache. Many people use the app server statement caches, but yeah, use the driver statement cache. Not a huge deal, but yeah, basically allows us to recognize when connections have been lost or and so forth, freeing up memory and so forth. For a lot of people using JDBC automatically configure auto commit. I think it's a default, and we recommend against it. It's far better to use an explicit commit in your application. Now, if you but that's so be it. You just have to decide which one's better for you. If you depend on the auto commit, in other words, your application, you bought it off the shelf or whatever, just uses auto commit. So be it. You have to use it. Obviously, you can't change it. But if you don't absolutely need it, disable it. Okay. We can work with it or without. There is, it's just better without it. Many cases, applications have auto commit configured because, unlike Oracle, some alternative databases require read locks. And auto commit is one way to remove those, release the locks automatically. You don't need those in Oracle, so who cares? Okay. For JDBC, make sure the replay database data source is using the OJDBC x.jar. Now, this is the replay data source or replay driver. This is app continuity. In other words, that's where the logic is. So you need to configure it for JDBC, either 8 or 11. Well, 8's the most common these days. Many of you will be on 6 or 7. You need to upgrade that to JDBC 8 at least. Okay, 11 is cutting edge, so I would go with the 8. I've mentioned this before, but the next point is return the connections to the pool and to end your request. If you don't, you're kind of negating the whole purpose of having a connection pool to share and reuse connections. Not so much sharing, but reuse them. So if you don't return the connection to the pool, effectively what you're saying is, I need a dedicated connection. Screw you. All you other people, I'm going to keep this connection forever. That means it's really difficult for us to do draining and replay and so forth because your request never ends. And so we come to drain timeouts. Well, it never ends. So we have to replay the entire session. Not a good thing. And typically it gets messy with a lot of commits thrown in there as well, right? So don't do that. Make sure you return the connection to the pool at the end of your request. It not only ends the request, but makes that connection reusable for other users, not just you. PL SQL seems to come up a lot. Not a surprise. It's a good processing engine. If you're using PL SQL, though, make sure you control the transactions outside PL SQL. Do not commit within the PL SQL. Now, there's a couple of reasons for that, but principally it is that during replay, When we see a commit, we kind of stop replaying at that point, because why would we replay a committed transaction? We're not going to do that. So as soon as we see the commit, we say, that's it. I'm not going to do it anymore. And we exit the PL SQL block. So if you've got a bunch more processing after that commit within the PL SQL block, it's not going to get touched or as part of the replay. So don't do that. And in fact, best practice has always been to keep commits outside the PL SQL block. Just use the block for the logic. It contains the application logic. But we see customers break this rule time and again. Commit a maximum of once per database request, for the same reason I just talked about, right? First commit we see is the end, because we don't replay committed transactions. Okay, and I'll show you an example of why that's an issue in a moment. Evaluate the replay as part of this, okay, as part of your routine testing procedures. Now, how do we evaluate the replay? Here it is. This is basically the last of it. So AC check is a utility available to you and DBAs to evaluate what in your application workload will replay as part of for application continuity or not. You got to think of app continuity as that insurance policy for when things go wrong. In other words, when there are interruptions injected into the workload. We want to use app continuity here to smooth over any of those interruptions. Okay, the insurance policy automatically kicks in for you. But as for all insurance policies, it's kind of like a bit of fine print. And AC check utility helps decipher what the fine print is. In other words, it tells you what is not actually covered. And typically, if you followed all the rules that I've kind of highlighted in the previous slides, you should be good. But occasionally, there's going to be some differences. And you can see in this report, if you notice here, right in the middle there, there's a protected calls percentage, 98.734. Sounds really good. But it suggests there's 1.266, is it, percentage that are not called, not replayable, and so forth. Okay. And it lists them down below. And you can see the first two lines there are disabled because there's a commit. And didn't I just mention that we do not replay commits? Well, these are examples of calls that follow a commit. So there are calls within the workload, the database requests, that within a particular request that follow a commit. And we disable on the commit because we don't want to replay that. So anything following it will not be processed or replayed. And some of the other details there. So this utility, there's a video available to show you how to use it. It is basically this, it's exactly the same across the board, whether you're using it in the cloud, Oracle Cloud, or on your on-premise databases. It relies on the DBMS app cont report functionality to process the workload, look at the workload and report on, in this case, the full report, and then detailed reports of what is available, what's not going to replay for you. There's 4 database views we've created to support this, and you can join those views as you wish. Free queries, okay? That's basically it. This should be part of your, adopted as part of the routine for any environment using application continuity to run this for any changes to the systems and so forth. It's very simple. And once you got permissions, you can do it anytime you like. Okay. For more information, you can go to the App Continuity product page. It's pretty straightforward. Go oracle.com, go to AC. You can actually spell it out too if you wish, but AC seems more appropriate. I'm writing it out all the time. I still get the spelling wrong sometimes. Okay. And then there are three versions of what we call the deployment checklist. Differences here, obviously, because the different platform. The general one, the first is going to be available for you for virtually everything. Okay, all the details are there. It augments what we have in our Oracle documentation, specifically for virtually all the details and examples of that are specific, and we update it routinely. It's rare that within a 2-week period that I'm not updating that document online. Okay. Same goes for the other two for ADB, the autonomous database, whether it's dedicated platform or shared infrastructure. We have slightly different versions because they have slightly different rules and requirements. But yeah, you're welcome to dig into those. Okay. Further on, we have hands-on labs if you want to actually test this out for yourself and see how it works. That first lab, Oracle RAC, HA and scalability for your applications, goes through the process, takes you through the process of creating those services and then running your application against them and testing failover, and also allows you to run AC check at the same time. Okay, so have a look at that one if you have a chance.